All right, this is from Unit 1 Review, question number 6. This is composite functions. And the easy way I like to explain this is we are taking a function or some math and we're plugging it inside of other math. So you notice right here, I have g of x inside of f. That means I'm going to take the math that goes with g and I'm going to plug it in to f. And likewise, when I get over here and I flip it, you'll notice f of x is inside of g. I take the math that goes with f and I plug it into g. Okay, so let's go ahead and start with the first part here. Okay, again, you'll notice g of x is on the inside. All of this math, x squared minus 29, is associated with g of x. And I'm going to go ahead and circle the math, and I'm going to plug it into f. So if I were to rewrite f, normally I'd have a large square root sign. Normally it would be x plus 4, but instead of x, I'm plugging in x squared minus 29, which is what g is. And I still have this plus 4 here. Okay, I'm going to go ahead and simplify this. Pretty much the only thing I could do here, I don't really need the parentheses, so this would just simplify to x squared minus 29 plus 5, which simplifies to x squared minus 25. And that's all I can do with this problem. Don't be fooled by the x squared and the 25. This subtraction symbol right here limits me from taking the square root of both of those, so that's as simplified as I can get. Okay, domain and range. Excuse me, just domain. We're going to do the domain on the calculator here, so I'm going to go ahead and turn my calculator on. I'm going to go to y equals, and then I'm going to go ahead and plug in the square root of x squared minus 20. Okay, and there it is typed in, square root of x squared minus 25 in parentheses if you have an older version of the text instrument calculator like I do. I'll go ahead and look at the graph, and this is the graph I get. And I'm also going to look at a table to help me figure out the domain. So when I look at a table here, I notice a bunch of errors. So mathematically, the calculator is not like 4, it likes 5. And again, we know that we cannot have negatives under a radical sign, and that's the reason. If I did 5 squared minus 25, I'd get the square root of 0, and I can have the square root of 0. And as I scroll up here, I notice it likes negative 5, and all the numbers less than negative 5. Okay, so it doesn't like the stuff in the middle here. So my domain, I can have all x values that are less than negative 5. In an interval notation, we'll write it like this. From negative infinity, comma, to negative 5. And I'm going to have a closed bracket because I can include negative 5 in my answer. And then u, and then it's going to pick back up at positive 5 and approach positive infinity. So those are all the x values I can use. And basically anything between negative 5 and positive 5 are not allowed because I would have negatives under the radical sign. Okay, we're going to go ahead and flip that. Let me go ahead and get rid of this calculator for a second. All right, this time I'm going to go ahead and get rid of this and this. I'm going to switch it. You'll notice I'll highlight in a different color. F is on the inside. This square root of the quantity x plus 4 is associated with f. I'm going to circle the math. I'm going to draw an arrow, and I'm going to plug it inside of g. So if I were to write this here, I would say instead of x squared minus 29, I'm going to plug in f inside there. So square root of x plus 4. Okay? And this is f being plugged inside of g. Now, I can simplify this. When I square a square root, okay, these will cancel each other out. And I would just get x plus 4 minus 29. And my final answer is going to be x minus 25. And I get this. Now, I do have to be careful with the domain on this, because if I first looked at this, I would say that if I'm looking at my final product here, this is linear. So I'd assume the domain is all real numbers. But I need to focus on this because there is a restriction here with this square root. So when I go ahead and type this in the calculator, y equals, I'm going to go ahead and move this over here, hit clear. I'm going to go ahead and type that original composition instead of my finished product. So I get something like this. And if I were to look at the graph, oh, I think my window's out. I better go ahead and open that window up a little bit. Okay, I changed my window here. I'm going to go down to -30 since I know my y-intercept's at -25. When I hit graph, I see this, and it does look linear. But I do notice that, I'll go ahead and pull this off here so I can write on it, that it does have a stopping point right here on my graph, which is a little odd. And the reason being is right here, I can't have negatives, so it likes -4 for an x value, but it doesn't like anything less than -4, like -5 is no good, -6 no good. So if I go ahead and look at a table here, so if you're ever confused by domain with graphing, look at the table, and then it's kind of cut and dry. -5 is not a number that I can use mathematically because I can't have negatives under a radical sign. It likes -4. It likes -3. It likes everything greater, and those are producing y values as well. Okay, so looking at this, my domain here would be -4 based off of this x value, and that would be closed because it does produce a y value, and it's going to go to positive infinity, open. And that's my answer for domain and range on question number 6, just domain, and the composite functions simplified, and why we get these restrictions on the domain, especially over here when I take g of f of x.